Okay, so this example 133 is taken from the R.C. Hibler book, and it is one of the numerical example in your tutorial sheet. Now, the tractor together with the empty tank has a total mass of 4 kilogram, 4 megagram. The tank is filled with 2 megagram of water. So this means that the given data. So the initial mass of the tractor and water and plus tank is 4,000 plus 2,000. That will become 6,000 kilogram. The water is discharged at a constant rate of 50 kilogram per second. So this means that dme divided by dt is 50 kilogram per second. With a constant velocity of 5 meter per second measured relative to the tractor. So the velocity of the d relative to e, or the velocity of e relative to d, will become equal to 5 meter per second. If the tractor start from rest, so the initial velocity of the tractor v naught is 0 meter per second. And the rear wheel provide a resultant traction force of 250 Newton, as you can see in this figure here. So this is the like a driving force. So F is given, which is 250 Newton. So this is the force of the both wheels. Determine the velocity and acceleration of the tractor at the instant the tank become empty. So what you need to calculate, A, acceleration is unknown and velocity is unknown. And you need to calculate this at instant. The tank become empty. Okay, so this is the yeah, so we need to solve this problem here. We need to calculate A and V when at the instant when the tank become empty. So there is 2,000 kilogram water in this tank here. So in this case, we will obviously apply the equation that we derive in the theory part. The summation of all the forces on the control volume is equal to m dv by dt and minus vd e and dme divided by dt. So this is the equation that we derived previously. Now, in this case, we have m. M is the mass of the system at any instant of time. Now we can see that the mass will change during the motion here. So we need to calculate m, which should be a function of time here. So we know that m, which is the current mass, should be equal to the initial mass, which is 6,000, and minus 50 t. So this is the current mass, and because the rate at which the water is getting out of the of the tank is 50 kilogram per second. So if you multiply 50 with time, so this means that you will get the mass of the water ejected from the tank at any time. So you need to subtract this from 6,000 here to get the mass. Okay, so if you just now put this value in this equation here, so the first thing is on the right hand side, on the left hand side, we have this forces, which will be this force here, which is uh, the outside forces. So 250 equal to, and m. So m here is variable, which is going to be 6000 minus 50t, and dv by dt, which is the acceleration which we need to calculate. So we will call this acceleration. And then you have minus v dE, which is this term here, which is 5, and dme divided by dt is 50. So you have all these terms here. So now we can we can simplify this equation. From here we can calculate a, which will become equal to 10 divided by 120 minus t. So this is our acceleration, which you can get from this equation here, which you just simplify this equation. So you will get this acceleration here. So this is the equation of the acceleration in term of time, and we can call this equation 1. So now we need to calculate t when the tank is empty. So the time taken to empty the tank, you want to calculate this. So obviously we can do this from this equation here. So in this case, similarly, because we know that 50 t equal to 2000. So 2000 is the total mass of the water, and this is the 50 is the rate. And if you multiply this with t, so you will get this thing here. And if we just say that this t dash is the time taken to empty the tank, and we will call this t dash, which we can calculate from here. So t dash will become equal to 2000 divided by 50, and that will be 40 seconds. So you need 40 seconds to empty the tank. So if you just put 40 in this equation here, so a will become equal to 10, 120 minus 40. So the acceleration will become equal to 0.125 meter per second square. So this is the acceleration that we get here, which was the first thing. And now we need to calculate the the velocity here. So to calculate velocity, we will integrate this equation with respect to time, because the acceleration is not constant, so we cannot just use the straightforward equation. So we need to do a proper integration here. So acceleration, which is equal to dv by dt, which is equal to 10 divided by 120 minus t here. So dv, 120 minus t into dt, and it will be from v0 to v, and this will be from 0 to 40. So in this case, it will become just equal to v, because this is 0, which is given here. So this will become v, and on this right hand side, as you can see, it will become equal to 10 and minus ln. If you just do this integration, so 120 minus t, and you just put the limits here from 0 to 40 here. So the limits is from 0 to 40. So if you put the limits, so it become equal to minus 10. So ln 120 minus 40, the upper limit, minus 120 minus 0, the lower limit, or v become equal to 10. Can say that it's ln and 120 divided by 120 minus 40. So if you just do the calculation, you will get 4.05 meter per second.